Hello student, in last lecture we have seen some definitions of a derivative, left hand side derivative and right hand side derivative. So in this lecture we will see theorems on a derivative, or we can say that differentiation theorem. So before going to start theorem on a differentiation, we will see again definition of the differentiation. So what is the definition of the differentiation? For that, let us we consider y equal to f of x be a function defined on some interval I. So let us suppose that del x be the small increment, or we can say the small change in x, and del y be the small change in y respectively. If the ratio del y by del x tends to definite limit as del x tends to 0, then this limit is called as a differentiable constant, or it is called as a derivative of y, or it is called as a derivative of f of x. So this is the notations dy by dx equal to f dash of x, and this can be written as limit del x tends to 0 del y by del x, or this can be written as dy by dx equal to f dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h. Right hand side limit exists. So this is the simple definition of the derivative. So on this base, we will see next theorem. So what is the next theorem? The statement of theorem is let the function f and g differentiable on interval I. Then we have to prove that f of x plus minus g of x bracket derivative equal to f dash of x plus minus g dash of x. Second part, k into f of x whole derivative equal to k f dash of x. So here k is a constant term. Third part is f of x into g of x bracket derivative equal to f dash of x into g of x plus f of x into g dash of x. So these are the three parts of this theorem. Now we will see one by one part of this theorem. Okay. So let us see first proof of the first part. So for this part, we have given f and g are the differentiable function on interval I. So let us suppose that let denote f of x, capital F of x equal to f of x plus g of x. So let us consider equation number 1. Now, by the definition of the derivative, we will apply definition for the function f of x and similarly for the function g of x. Then by the definition of derivative, this can be written as f dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h. And for the function g of x, it is given as g dash of x equal to limit h tends to 0 g of x plus h minus g of x divided by h. Now, from equation number one, from equation number one, here f of x and g of x both are the differentiable function. So therefore, we can say that f of x is also differentiable function. Okay. Now, so we will use this derivative for the function capital F. So which implies f dash of x equal to limit h tends to 0 capital F of x plus h minus f of x divided by h. So put the values of capital F of x from equation number 1, that is f of x plus g of x bracket power bracket derivative equal to a limit. So instead of x we will replace x in equation number 1. So f of x plus h plus g of x plus h minus f of x is as it is from equation number 1, f of x plus g of x divided by h. So simple, here we have used equation number 1 notation form. Now left hand side as it is, f of x plus g of x bracket derivative equal to limit h tends to 0 as it is. Okay, so what is here? So we will take f of x term, f term, uh, let us we combine the f of x, f term and g term. So f of x plus h minus f of x in first bracket, and in second bracket let us we combine term g and g of x. So g of x plus h minus g of x divided by h. Okay, what is next term? So left hand side as it is equal to limit s tends to 0 as it is. Okay, so we will separate this term. We will separate this term and taking a limit to both term. Okay, so if limit h tends to 0, f of x plus h minus f of x divided by h first term plus limit h tends to 0, g of x plus h minus g of x divided by h. So here we have simply separate the terms because here is plus sign. So therefore we we expand, or we can see the take the addition of the bottom separately. Okay, so what is this? So this is the derivative of f of x and this is the derivative of g of x. So therefore by the definition of the derivative we will apply here definition. So left hand side as it is, left hand side as it is equal to f dash of x plus g dash of x by using the definition of the derivative, and hence we can say that f of x plus g of x bracket derivative equal to f dash of x plus g dash of x. So here dash is denoted as a derivative. Okay, so this is the proof of the first part of this theorem. Now we will see the second part of this theorem. We will see the second part of this theorem. What is the second part? We have to show that k f dash of x equal to k f dash of x. So for that we know that the definition of the derivative. So by using the definition of the derivative, because f is a differentiable function on a interval I. So therefore by the definition of the derivative, f dash of x equal to limit h tends to 0, f of x plus h minus f of x divided by h, because we have given f is a differentiable function on interval I. Okay, then we know that here k is a constant. If you multiply k to the this function, okay, then we get k into f of x bracket derivative equal to limit h tends to 0. So in k into f of x plus h minus k f of x divided by h. So here we have simply multiply k to this function. बरोबर, इथं जर k ने जर मल्टिप्लाय जर केलं तर या टर्मला सुद्धा k ने मल्टिप्लाय होणार आहे आणि या टर्मला सुद्धा पण k ने मल्टिप्लाय होणार आहे, कारण की k काय आहे इथं कॉन्स्टंट आहे. ओके, आणि नेक्स्ट स्टेप. सो k इंटू f ऑफ x ब्रॅकेट डेरिव्हेटिव्ह इक्वल टू, आता k काय या ठिकाणी कॉन्स्टंट आहे. सो टेक k इज अ कॉन्स्टंट आउटसाइड ऑफ दिस लिमिट. So k equal into limit h tends to 0, f of x plus h minus f of x divided by h. Okay, so what is this? So this is the derivative of the f of x. So therefore by using definition of the derivative, this term can be written as f dash of x. So therefore left hand side is k into f of x bracket derivative equal to, this k is as it is, and by using definition of the derivative this term can be written as f dash of x. So k f dash of x, where k is a constant. So this is the proof of the second part of this theorem. Now we will see the third part of this theorem. Third part of this theorem. So for that we will consider, or we will denote capital F of x equal to f of x into g of x. Let us we consider equation number 2. And also we have given small x and g are the differentiable function on a interval I. Okay, so therefore by again using definition of the derivative, so this term can be written as, by using definition of derivative, f dash of x equal to limit h tends to 0, f of x plus h minus f of x divided by h. And for the function g of x, derivative can be written as g dash of x equal to limit g of x plus h minus g of x divided by h. Okay, so by using the simple definition of the derivative, we can write f of x in this way and g of x in this way. Now, from equation number 2, f of x and g of x, we know that both are the differentiable function on interval I. So therefore, we can say that capital F is also differentiable function on interval I. So therefore, by again definition, so here f is also differentiable function. So therefore, by definition of the derivative, so this term can be written as capital F dash of x equal to limit h tends to 0 f of x plus h minus f of x divided by h. Okay. So now using equation number 2, put the values of f of x. What is equation number 2? F of x equal to f of x into g of x. So simply put the equation number 2 values capital F of x. So f of x into g of x bracket derivative equal to limit h tends to 0 f of x plus h into g of x plus h minus f of x into g of x divided by h. Simple by using equation number 2. Okay. Now, to simplify this term, we will add and subtract f of x into g of x plus h for the simplification of the term. Okay. So limit h tends to 0 as it is. F of x plus h, g of x plus h, this term is also add as it is. Okay. So what we have done here? So here we have subtract f of x into g of x plus h and plus add f of x into g of x plus h. Okay. So there is no change in this term. Okay. काय केलं आपण सिंपल या ठिकाणी f of x into g of x plus h हा काय केला सबट्रॅक्ट केला आणि इथंच हा ऍड केला म्हणजे काही त्या टर्म मध्ये कुठल्याही प्रकारचा चेंजेस होणार नाही. Then minus f of x into g of x, this term as it is, this term as it is. Okay, divided by h. Now, what is next step? Left hand side as it is, limit h tends to 0. Okay, what is next step? So here we will take g of x plus h and g of x plus h common term. Okay, then remaining terms are f of x plus h minus f of x ब्रॅकेट कंप्लीट इंटू जी ऑफ एक्स प्लस एच कॉमन टर्म. या ठिकाणामधून आपण जी ऑफ एक्स प्लस एच ही कॉमन टर्म घेतलेली आहे म्हणजे ब्रॅकेटमध्ये कोणती टर्म राहणार आहे एफ ऑफ एक्स प्लस एच मायनस एफ ऑफ एक्स. दिस इज नॉट अ डेरिव्हेटिव्ह, दिस इज अ ओनली एफ ऑफ एक्स. ओके, प्लस या टर्म मधून आपण एफ ऑफ एक्स कॉमन घेणार आहे इथून आणि इथून म्हणजे ब्रॅकेटमध्ये काय राहणार आहे जी ऑफ एक्स अँड g of x plus h minus g of x into f of x. This is a common term divided by h is as it is equal to left hand side as it is. Okay, limit h tends to 0. So separate the limit, प्रत्येक term ची limit घ्या. So f of x plus h minus f of x, this first term divided by h into limit of this term, limit h tends to 0 g of x plus h. Okay, then plus limit h tends to 0 g of x plus h minus g of x divided by h into limit h tends to 0 f of x. बरोबर, सेपरेट केला आपण या ठिकाणी काय केलं लिमिट प्रत्येक टर्मचा लिमिट घेतलेला आपण apply the limit to each term. Okay, so what is this? So this is the definition of the f of x and this is the definition of the g of x. So therefore, by using the definition of the f of x and g of x and take limit h tends to 0, because here g of x is a differentiable function and which is a also continuous function. So therefore, by using the definition of the f of x, so this term can be written as f dash of x and h replaced by 0. या ठिकाणी h जिथं असेल तिथं 0 put up करा, so you will get simply g of x plus limit. This is the definition of the g of x. This can be written as g dash of x. Okay, so limit h tends to 0. या ठिकाणी काहीच फरक पडणार नाही म्हणजे f of x च राहणार आहे. Okay, so hence left hand side f of x into g of x bracket derivative equal to f dash of x into g of x plus g dash of x into f of x. So this is the third part of the this theorem. So this is the complete proof of the theorem on a differentiation.